Question number 1, right? You were asked to calculate, you asked to make a 250 milliliter solution of a 0.45 molar sodium hydroxide solution. You had to figure out grams of sodium hydroxide that the student used to make the solution. So the very first thing that you have to do here is we have to use the molarity formula, and we have to solve for moles. So that's liters times molarity is equal to moles. And so the volume that we were working with is 250 milliliters, so I had to change that to liters. And the molarity that you want to get is 0.45 molar, which is going to be equal to moles. So in this case here, the concentrate, when you calculate this out, you get a value of 0.1125 moles of sodium hydroxide. So that's the mole part. And some people stopped at this part and then they didn't quite finish. Some people rounded this to 0.11. That's okay. I'll figure it out when you take the test or the quiz. The next part about this, the next thing that we have to do then is we have to go ahead and calculate mass. So I'm going to take the 0.1125 moles of sodium hydroxide, and I'm going to convert it to grams of sodium hydroxide, so mass to mole. So I'm going to put the 1 mole of sodium hydroxide on the bottom, and I'm going to put the molar mass, which is 39.9364 grams of NaOH on the top. Multiply that out correctly, you should get an answer of 4.50 grams of sodium hydroxide for the problem. Now again, if you rounded at this point and you got like 4.4, I gave you credit for it. Okay, because I mean, it's just a rounding issue. So that was the first one, and a lot of people did okay with that. Second one, it says the same student takes 5 milliliters of a 0.45 molar sodium hydroxide solution from problem number 1 and dilutes it to 100 milliliters. Dilute should have been the dead giveaway that you should have used this formula here. M1V1 equals M2V2. And in this case here, the original concentration that you're going to work with is 0.45 molar NaOH. And the student used 5 milliliters of it. Okay? And then they diluted it, and we have to calculate the second concentration, but they diluted it to 100 milliliters. So in order to solve this problem, we're going to divide both sides by 100 milliliters. And we get M2's concentration, which should be 0.0225 molar NaOH. Now, that should make some sense to you. Like, if you start with something that's pretty concentrated and you take a small amount of it and you fill it up with 100 milliliters of water, it should make some sense that the next concentration is going to be significantly less. I heard somebody when they were taking the quiz, and I don't know who it was, I don't know if it was here or later or earlier today or whatever, somebody said, oh, that doesn't look like, they crossed it out, and then they did a different calculation and they got the wrong answer. Okay? It should make sense that if you start with something that's concentrated and you're in a small amount of it and you're adding a bunch of water to it, that the concentration is going to go down. That should make some sense. Yes, Alex?
Why did you call that
units of volume cancel out. I mean, algebraically they cancel out. And so I was just trying to prove that you end up with molarity. Does that make sense?
Yeah.
Okay. Now, with the written portion, this is literally what I was looking for. I told you to, in a paragraph, describe these steps the student followed when she performed the dilution in question number 2. You should use words flask and pipette, include actual volumes, which are numbers, in your paragraph. I wanted you to say that the student extracted 5 milliliters of a 0.45 molar sodium hydroxide solution using a pipette and transfer it to a flask. Then I needed you to say, carefully fill the flask to the 100 milliliter mark, being careful to not go over. I get that I said careful twice in the same sentence, and that's like, you know, sort of wrong, but I think that you get the idea. Yes.
Okay, so like if you extract 5 milliliters, it still means there's 0.45 molarity in there?
Yes. If I take orange juice, right, and let's just say the concentration of orange juice is 10 molar. If I take a sample of the orange juice and I pour it into a tiny, tiny glass, and I've got a big jug of orange juice and a tiny, tiny glass of orange juice, this is still 10 molar. I haven't changed its concentration. Does that make sense? I've just got a tiny sample of it. And then if I take that tiny sample and I put a bunch of water in it, then I change the concentration. Does that make sense? Okay. Now the other thing is some of you wrote a lot of information, like you described how you did problem number 1, and then you wrote this. If I don't ask for how did the student create the solution, I don't want to know about it. So understand what the problem is asking you to do. Don't tell me more. Don't tell me more in a paragraph like this, because it irritates me when I have to grade it because I have to read way more than I should. And plus, it sort of kind of makes me wonder if you really know what's going on or not. More is not always better, right? At some point, when you go to the Tozino's and you eat too much pizza, it's not always better, right? Like you feel like garbage for like the next 4 hours. I know, but it's not always better. Problem number 4 said calculate the pH of a solution that is 2.46 times 10 to the minus 4 molar hydrochloric acid. So is this an acid or a base? So we had 2.64 times 10 to the minus 4 molar hydrochloric acid. Acid or a base? What is that? Acid or a base? Acid, how do we know it's an acid? It has hydrogen, right? So if we can know acid, we can know base, or not base, we know H3O plus. So in this case here, we're asked to find the pH, and the formula that we have to use in order to calculate pH is pH is equal to the negative log of H3O plus. And since this is an acid, and this is the concentration of the acid, all I have to do is take pH is equal to the negative log of 2.64 times 10 to the minus 4 molar. I don't have to do anything extra. That's all that I have to do. So then when I calculate this using the calculator, pH is 3.58. Do me a favor, from this point forward, any calculation that you do that involves calculating the pH, just go to 2 decimal places no matter what. Okay? No matter what you think it should be, just go to 2 decimal places. So that was this one. So far, so good? Okay. Last one was the most common place where people made mistakes. Okay. You were given a pH of 11.32, and you were asked to find OH minus. Okay. Out of the formulas that we work with here, there's one that that calculates directly to OH minus, and I get that there's at least 3 different ways that I can think of in my head to solve this problem. I'm going to show you the way that I did it on my sheet, which for some of you may be longer than the way that you did it. Okay? Here's what I recognized. I recognized that I was given the pH, and given the pH, I can calculate H3O plus using this formula here, 10 raised to the negative pH. So H3O plus equals 10 raised to the negative 11.32. So ultimately H3O plus will equal 4.79 times 10 to the minus 12. At this point, I can now use my KW formula to solve for OH minus. So KW equals H3O plus times OH minus. KW always has a value of 1.0 times 10 to the minus 14. We just calculated H3O plus as 4.79 times 10 to the minus 12, and that allows us then to solve for OH minus. So I'm going to divide both sides by 4.79 times 10 to the minus 12. And when all is said and done, the concentration of hydroxide, your calculator might have given you this, which is correct, or you might have written this. Both are correct. They just both happen to mean the same thing. Okay, so those were how we did the problems to every single one of the ones on the quiz. Any questions about that?